Hey everybody, welcome to AE430 controls. On this problem, what we're going to do is we're going to do a block diagram reduction. And what we have is this basic block diagram system. Well, it's not basic, but we have to get the transfer function from it. G of y over u, so output over input. This one's a little bit tricky. If you've had anything to do with block diagrams, you'll see that we have a couple of nested loops here, which can make it a little hairy because you can't just take this loop and run with it and then take this loop and run with it. You actually have to separate the loops so that you can actually define them. So that's what we're going to go through here. But first off, we're going to grab what little we can and see if we can reduce anything as it sits right now without having to do any big rearranging. And you can actually see that right here, this piece, this little loop right here, this little feedback loop, can actually be reduced as it sits right now because it does stand alone. Yes, this line comes off of it, but if you want to, you can actually redraw this, take this line, and move it out and over and around like that. So now you have just this little nested loop, and then outside of it, this line is here. And you can do that because this 1 over s is transferring to the 2, then it's also transferring to the 4. So the same signal is going to both lines. And so you can treat them completely separately. So you can work with the 2 and 1 over s without touching the 4. So we're going to do that first. And what it reduces to is 1 over s plus 2. The way the feedback loop, the calculation for finding this block, this is the 1 over s with the feedback of 2. The calculation for that is g over 1 plus g h. And in this case, 1 over s is g and 2 is h. So if you do that out, you have 1 over s plus 1 times 2, or plus 2 times 1 over s, which is 2 over s. And then you distribute that s through there so you don't have fractions and fractions, and you get 1 over s plus 2. And that's your block right there. So now you have this new set of block diagrams, and it's a little cleaner, it's a little nicer looking now, because you don't have that 2 in there confusing you. But we still have this nested loop. We have this one starting right here, and this one started right here. So in order to do that, we need to either bring this point back over here, or this point back over here, so that you can get 2 separate loops. The actually easiest way that I've known to do this is to just transfer this block through the junction like this, and you just split it up, because 1 over s plus 2 is going through this line, that's also going through this line. So you just move it through the junction and put 2 1 over s plus 2's there. And what you'll end up with is this kind of a setup, and you can see I kind of redrew it. So you have 1 over s plus 1, you move the 1 over s plus 2 into this junction, and you have 1 over s plus 2 times 4. And now this junction is freed up because there's just a line here, and you can move it back here. And then on this side, it's the same deal. You move 1 over s plus 2 up to here. So now you can imagine that is just a line going through here with 1 over s plus 2 right there, and this part. So that gives you this feed forward loop. So now we have a feedback loop and feed forward loop. It's really not that hard to do. So doing this, it's g over h over 1 plus gh again. So this is g. This bottom half is h. The feedback is always h. The forward part is always g. So 1 over s plus 1 plus 4 over s plus 2, that's the h. So 4 times s plus 2, because when they're in a series like this, it's always a multiplication. Like that. So 4 over s plus h, so that's h times g, which is 1 over s plus 2. So if you distribute this out and then try to start simplifying denominators again like we did up here with the 1 over s. I'm kind of skipping some steps, but you should be able to do that algebra of simplifying the denominators. You'll end up with s squared plus 3s plus 2 plus 4. And the 4 is what's left from here after you get the common denominator in the bottom. And then s plus 3s minus, plus 2, can't see the plus right there, is the result of multiplying these two together. And you put that up here, so you're multiplying by the top and the bottom by the same deal in order to get the common denominator. So you're multiplying the top by the same polynomial, and you have s squared plus 3s plus 2 over s plus 1. Now if you want to simplify that, you actually factor this out again, or remember that it's just this factor right here. So the s plus 1's cancel, because this factors to s plus 2, s plus 1. Cancel the s plus 1s, and you end up with s plus 2 over s squared plus 3s plus 6. And that's the the function, the equation for this entire feedback loop right here. And then over here, it's a feed forward loop, so all you have to do is add the two halves of the loop together. So s plus over s plus 10 plus 1 over s plus 2, you get the common denominator by basically cross multiplying these two here. Add that all up and you have s squared plus 3 plus 10. So then continuing from there, this is what our block diagram looks like now. Two easy blocks. All we have to do is a multiplication. So multiplying those two together, you just going straight across here, you have s times s squared, which is s cubed, s times 3s squared, s times 10, 10s, and then 2 times s squared, 2s squared, then 2 times 3s, 6s, then 2 times 10, 20. And then on the bottom, doesn't change. So this is your transfer function, simplified a little bit more. And this is your, this would be a block, your last final block, which is y over u. That's a very bad view. That looks almost like a y or something. This is your transfer function. And you'll see you'll have a higher power in the top. That's okay. But if you're ever putting it into like MATLAB or something, you need to do some kind of manipulation with this so that there's a higher power in the bottom. Because theoretically it's okay, but when you start trying to simulate it, it gets hairy when you have a higher power in the top. Just because of the rules of the program and how transfer functions are supposed to work. But this is basically your transfer function. You can either put it in this block like this, or set it equal to y over u, however you want. But that's how you reduce a block diagram.